Hey everybody, Mr. Mack here. In this video, we're looking at Detroit's population part 2. We're looking at the years from 1950 to 2020. And in the first part, we looked at the population from 1815 up through 1900 something. And we saw that it was an exponential growth. And we saw some reasons why it did that, some economic factors and some things like migration and pandemics and cholera, things like that. We're looking at 1950 to 2020, and we can see, I gave you a word bank right here to describe what you see here of the population from this period. And it's going down, but how is it going down, right? How would you describe using maybe some of these words? And notice that at the height here, we're almost at 2 million. Looks like maybe like, I don't know, 1,750,000. And then by this point in 2020, it's down to almost 600,000. So that's an impressive decline. We're going to be looking at modeling with an equation this declining population of Detroit. But first, let's take a look at how we model. I'll give you some examples on how we can model. Stop. Let's turn this off. How we can model linear relationships, and then we'll look at exponential growth and exponential decay. So let's look at linear. I want to make a line of best fit that goes through this scatter plot. And so we're just going to take a ruler and we're going to try to estimate a line here. And so when we do this line, we want to try to go through as best we can, cutting the scatter plot so that there are same amount of points on above the line as below the line as we go, left and right through those points. I didn't do a very good job here. I got these 2 points below, and I've got these 2 above, but it's not really going through like I want it. So let's try it again. It's a little bit harder for me on this using this app here. So let's try it again. Let's get a different color here. So that's not a line. Maybe something like this. And that didn't change that color. Let's try it again. Okay, yeah, maybe this is pretty good. So it's going maybe just a little bit more, a little lower here. Yeah, maybe, what do you think? Maybe like that? Okay, so I'm gonna stick with that. And so we want to choose 2 points on this line. Let's see, that point seems to work there. Okay, well G works, and I guess A is right on there too. And it just happened to go through that. But I think this looks pretty good. I've got these. Yeah, it's close. So we'll go with that for this example. And so I've got A here is at 2, 1. And G here is at 11, 8. 11, 8. And so we're going to use those 2 points here. So I've got, with these 2 points, we can come up with a line for this scatter plot. All right. So we know the equation of a line is y equals mx plus b, and m is the rate of change or the slope, b is the y-intercept, and x and y represent points that lie on the line. Well, there are infinite points that lie on this line, but I've got these 2 points that I know that lie on my coordinate grid. And so we can find the slope first, and then we can get the y-intercept. So the slope, as we know, we call it the rise over run, or the change in the y values over the change in the x values, right? So rise is the change in the y, and the run is the change in the x. The change, another way to say that, is the difference of the y's and the difference of the x's. And I could say A is being my first point and G here being my second point. And we can just substitute now y2, 8 minus 1 over 11 minus 2. 8 minus 1 is 7. 11 minus 2 is 9. So my slope is 7/9. Okay, now we can take the slope and we could put it back into our equation. So I got m, I need to get b. What can I use for x and y? Well, x and y, there are infinite set of points that work for a line. We've got these 2 that we know work. Let's just choose one of these. So I'll go with A. I'll use point A here. So I can put in here. Let's use a different color. So I've got y equals mx plus b. Let's put in 1 for y. I've got 7/9 for my slope. And x here is 2. Make sure you use the same x and y and the same point. So I got 1 equals 14/9 plus b. And then now I can subtract 14/9 to the other side because I'm trying to solve for b. I can rewrite 1 as 9 over 9. And b is negative 5/9. So negative 5/9 is almost a half, negative a half, and we could see if we extend this line here, I didn't quite do that well, but you could see it should be hitting, that's our y-intercept. So let's put the whole thing together. Our equation is y equals m, which is 7/9, x minus 5/9. Okay, that's the equation that models our data on this scatter plot. Okay, example 2, we have an example here of an exponential growth equation. And I want to find, so we have the graph, I want to find the equation. So here I've got 2 points that are identified here. This is at 2, 4. And this one right here is 4, 10. All right, so I have some steps here for you. So we did step 1, identify 2 points. Plug both sets of coordinates into the general form of an exponential equation. So here's our general form. So y equals a times b to the x. And a is our initial point. B is the growth factor or the decay factor. In this case, it's growth. And x and y are going to be points that lie on the curve. So what we're going to do is, let's do this and do point A here. So let's do point A. I'm just going to substitute 2 and 4 into our equation. So it's going to be 4 is my y, right? This is a y value and this is an x. 4 equals a times b to the second. And then I've got my other equation here using 410. 10 equals a times b to the fourth. All right. Now, what we're going to do, so we just did step 2. Now on step 3, we're going to solve the equations for a. So I'm going to divide b squared to both sides. On this one, I'm going to divide b to the fourth on both sides. And so now I've got a equals 4 over b squared. And in this one I have I'm going to write it this way, a equals 10 over b to the fourth. These two a's are the same because they're both modeling, we're looking for the same equation, right? So we can just say these a's and b's are the same. If these are the same, I can just write 4 over b squared equals 10 over b squared. B to the fourth. And so we need to get b by itself. We just solve for b. So how about we multiply b to the fourth here to this side. So that cancels. And that's supposed to be a 4 there. 4b to the fourth divided by b squared is 4b squared, right? Remember our exponential rules. B to the fourth divided by b to the second is b squared. And then we're going to solve for b here. Take the square root of both sides. Okay, now I've got, I did that. I found a. Now I need to solve for b. So once we have, I got b, sorry. So substitute values of a and solve for b. I got b. Now we need to get a. So now we're going to do step 5. We could use either one of these equations. I'm going to use this one because it's going to be a little bit easier. So I've got 4 over b squared. Let's see here. Is that what I would do? Yeah, I could do that. 4 over b squared equals a. Now I'm going to substitute the b in here. So I got 4 over square root of 10 over 4. And we're squaring that, right? Just substituting the b in right there. So what happens when we square a square root? Okay, these are inverse operations. They cancel, right? So I get 4 over 10 over 4. And now we have this compound fraction here. We don't want that. So this 10/4, how about we multiply this by its reciprocal, top and bottom. So we get rid of this fraction in the denominator because 10s cancel, 4s cancel, and I get 16/10 as my a value. Or, we could simplify that to 8/5. Okay, so I've got my a value, I've got my b value. I can write my equation. Y equals a 8/5. B is root 10 over 4 to the x. There we go. Check your solution with the other equation. Okay. So let's put what if we were to put a here in for the other equation? So 4 a equals 10 over b to the 4. So b in this case was root 10 over 4 to the 4th, right? Okay, so we would get a equals 10 over, so this would be 4, so this is a square root, so this would square this, so this would be 100 over 16. Goodness, can't get it to work. Okay. So we are going to now, let's see, did I do that right? Yes, so 16 over 100 times 16 over 100. So the 16s cancel, 100 cancels. And let's see, so this gives me 160, let's just do it this way, 160 over 100. So the zeros cancel, and then this simplifies to 8/5. Oh, that's what we got here before, right? All right, so it worked. We get the same value for A. All right, so here is my equation for this exponential growth equation, model, graph. Let's do one more. Example 3, we have the same situation here, except we have a exponential decay. Let's identify these points. I've got 1, 8. I've got 1, 2, 3, 4, 2. All right. We're going to take these equations. We're going to take the exponential equation here and substitute 8 in for y. A b to the first, and then I've got 2 equals a b to the fourth. Okay, so let's solve for a. A equals 8 over b. And here I've got a equals 2 over b to the fourth. Substitute the a's in, so I get 8 over b equals 2 over b to the fourth. I'm going to multiply b to the fourth to the other side. B to the fourth divided by b is b to the third, so I get 8 b to the third equals 2. Divide by 8, both sides. B to the third equals 1/4. B equals 1/4. We could say this is cube root, right? We got to take the cube root of both sides. I think I'll write it like this: 1/4 to the 1/3 power. I write the cube root as 1/3. Okay, so now let's put that in for this b here. So I got this b right here. So I got 8 over 1/4 to the 1/3 equals a. And let's see here. kind of ugly. So I could leave it like that, I guess. Let's put in, let's put this back into our equation. So we got y equals 8 over 1/4 to the 1/3 b 1/4 to the 1/3 raised to the x. I might just go ahead and pop these into a calculator so that makes this a little more simple for us. So we got, I did this first, this coefficient here. I get 12.7 to the 0.63 to the x. All right. Check your solution of the other equation. All right, let's put it into the other one here. A is 2 over b to the 4th. So I got 1/4 to the 1/3 raised to the 4th. So I'm just going to put that in my calculator. 2 divided by 1 divided by 4 raised to the 1/3 to the 4th, and this gives me 12.7. Good, that's what I wanted. Excellent. So here's my equation right there. 12.7 times 0.63 to the x power. Okay, I hope that makes sense. Some of these values we got were a little unwieldy, but it ends up working. And the next thing to take a look at is modeling back to the city of Detroit's population from 1950 to 2020. We're going to generate a linear model and then an exponential model, and then got some questions and then some further predictions to do. Good. So I hope that makes sense, and I'll check you all later. I'll see you.